discussion or subject matter. It's going to be talking about. I'm going to be talking about mold supports. Okay, when if all you ever did was make plaques, let's say, and most of your metal was being poured into the drag, and all you had was a solid coat forming the back of that plaque, you would never have to worry about mold supports, providing you were just making a small plaque. If you make a big plaque, you're still going to need supports. Now, when I say supports, normally if you've got a wooden pad or wooden flask, wooden cope and drag, top and bottom, you can do any number of things to keep the sand from accidentally falling out. Okay, first you ram it up good and tight so that the sand is pushed against the sides of the flask, and therefore is being held by the pressure of the wood trying to push back. Okay, the flexibility of the wood trying to push back against the sand, and therefore the equal opposite reaction kind of thing, so that the sand is being gripped by the flask and won't fall out as a single brick, so to speak. You can do that, or you can put a strip inside, a small thin strip about 1/8 inch, nothing really big that'll take away from your capability of working with the sand, but something enough that the sand itself will, when you ram it up, form over that ledge, and will be held by that ledge that the wooden strip represents. Or if you're making like a larger plaque, like let's say 12 inch by 18 inch or something like plaque, you might wind up having a flask that looks like this. Cue the first picture. Alright, this one, you'll notice, you look close on the inside, you've got some cross beams inside the flask. Okay, that you might wind up using just to support, keep the center of the sand mass from falling out, because don't forget, no matter how hard you ram it, there's going to be a little bit of flexibility in there, and you've got to compensate for that. If you just rammed it up, and you and another person picked up something that was a little bit larger than that, and you guys aren't treating it like nitroglycerin, as soon as you lift it up fast, or lift it up faster than you should, gravity is, and momentum is going, or inertia, you have to overcome inertia. Inertia is going to be holding that sand in for a millisecond or so in the same place it was before you started lifting, and the thing might just go like this, and the center of it fall out, and then the rest of it may fall out or may not. If any of it falls out, you're going to have to do the job over again. Okay, so you just need to put supports in there. Wherever you put your supports, though, don't forget you can't put it in the way of any risers you might be putting in there, or any your down sprue, your pouring basin, and anything you've got any holes and channels you've got to cut. And basically, you're not going to be putting it in the drag. Okay, you're not going to be, unless you intend on turning the drag upside down for any reason. The drag is going to stay flat, and gravity is going to hold everything in place for that. It's just usually just the cope that winds up being picked up and maneuvered, unless you take the drag and you turn it on its side. But even then, the framework of the flask is going to hold it in place, and whatever you set the flask, the drag of the flask on, that's going to hold it. So the sand shouldn't just topple out unless you didn't ram it up nice and tight. So most of these supports you're basically going to speak of, or I'm going to speak of, discuss with is going to be for what's going to be in the cope. Cope. All right. Because that's the one who's going to be opened up, lifted, put back down, moved around, and that's the dangerous one. All right. Now, if you have basically just everything is flat, cross beams in the cope is going to do. It'll be sufficient strength to hold the sand in place, and things shouldn't fall out. But you never know. Okay. Let's say you rammed it up, you've got your cross beams in there, and then you and another person picked it up, but a part of the cope fell out. The weakest part fell out. All right. Let's say that the part that fell out was no bigger around than like your hand, and no thicker than maybe your hand. Okay. For some reason, it wasn't rammed hard enough, or it's just in the right position, far enough away from any supports that it wasn't strong enough and it fell out. Well, thin things like that, or things that don't need real heavy duty supports, can be supported by what's called facing nails. Okay, these are facing nails, and they look a lot like roofing nails, except normally, the heads are bigger around than a normal nail you would drive into wood, because you want to have a lot of sand supported by these facing nails, and they're not going to be so long that they're going to go all the way through the top of your cope. Okay, what you're doing is you're just trying to support or fortify a thin minor section of your pattern. Okay, now the bad news is that you've got to be very careful when you're using these. You really don't want to have those in contact with the or exposed to the mold cavity itself. Okay, if you have it exposed to the mold cavity, you have a problem with the molten metal might fuse with the even if you're going to be using let's say brass and bronze, it'll still try to attach itself, even if it you break it off fairly easily if it's steel that you're using as nails. But the thing is that you don't want to use anything that has galvanized on it, no zinc coatings on it. The zinc itself will be burned off and be added to your casting. Might wind up being a bad casting defect. Nothing dirty. Okay, it's got to be absolutely clean, because any oil or dirt on the nails that if you have no choice but to have it come in contact with a mold cavity, that can be added to your your casting, and make that a defect in there. In addition, if you have a place in there that you can't mess with, it's thinnish, and you need to have the hottest metal go in there, you got to put those supports far enough away from the inside of the mold cavity that the steel that nail is made of can't act as a minor chill on that wall right there. Now, I haven't really spoken of chills too much. I did it in I think it might have been in risers. I might have touched on it very quickly. Directional solidification, I think that's where I just touched momentarily on the use of chills. But if you're using steel, that's going to draw heat out of your molten metal just a touch faster than anywhere else. Okay, so if you have to put those supports in a place that needs it, but it's in a part of your casting that's thin, make sure you bury those supports in about 1/8 inch, 1/4 inch of sand, and then cover that over with some, use your tool, either your slick or your trowel, to put a layer of sand over that to hide, act as an insulator over the steel, because it's going to have a chilling effect in that area when it comes to solidification, and it just might wind up being a problem. Okay, so facing nails shouldn't be in contact with, exposed to the mold cavity itself. And if you're going to use them because you're having a problem with a small area, make sure you bury it in there enough that you can put a covering of sand over it to minimize the chilling effect that the steel will have on your molten metal. There's another picture here that shows another type of support. Now, I think almost everybody that's ever worked with insulation on a ship can recognizes these real quick. But it's basically, when insulation, you buy these nails on the back side of the nails that's got a sticky material. You put those on flat spots, like on your bulkhead, on the wall of the ship, and you can push the insulation over those nails, and the nail points are sticking out. Then you put a little collet, another piece of metal that's got a hole in it the size of that nail. You push it on there just enough to where you barely push the insulation in, and that assembly is supposed to keep the insulation from falling off the bulkheads, and support everything so that it stays that way. In this case, though, what you're doing is that you're going to have a nail, and you're going to have an area that will support more sand rather than the smaller the nails that have the heads that are only about that are the same size as a roofing nail. Okay, you can make your own. For instance, anybody who's got metal shears and has got their own supply of long nails, you just cut yourself. Let's say you only have to have a square inch that needs to be supported. Chop yourself a square inch of sheet metal and drill a hole in the middle of it where a nail can go in, and then you just sink that into the sand that you're ramming up, and that'll support it. But you got to keep in mind that the no contact, and you're still running the risk of having a chilling effect on your molten metal. Okay. Now, the next mold support. This is a picture of a theoretical casting, a cross section of the mold for a theoretical casting. One could imagine that this is the cover going over your exhaust manifold, or something that goes over the where the what is that, well, let's say exhaust manifold on your car. Okay, this could be an exhaust manifold, and normally I would try my darndest to not suspend a weight of sand where it's going to be just hanging like this example shows. Okay, if I had any chance whatsoever of doing so, I would make certain that I had, I turned this whole thing upside down where that sand would be in the drag. But in this case, I mean, you could do that, but if you put your ingates up there, which is, looking at this picture, at the bottommost portion of the mold cavity, if you draw your ingates into that, you're going to have a little bit of work you need to do to try and and make that look neater. When it comes to the way it's run right now, it's much easier to put your ingates into that mold cavity, and then to clean off the ingates when it comes time to clean the casting. There's reasons why somebody has to have a green sand core being suspended just like that. There's going to be reasons. I myself still, would probably have taken this example and turned it upside down. Okay, I would have rammed up the cope first, turned it over, rammed up the drag, turned the whole assembly over, and make it to where what's in the drag right there in that picture would be in the cope, and what's in the cope in that picture would be in the drag. If I could. Now, we're going to make the assumption that you can't. There's some overriding reason why you can't, and we're going to pretend that it's because we don't want to put the the risers or the ingates anywhere else but right at that parting line right there. Okay, now, having said that, what you're looking at in that mold, in the sand that's been rammed up in that sand, is called a soldier. Now, why is it called soldier? Well, back in the time and in the place where that soldier was devised as a mold support, the most professional military at the time was the British soldier. Here's a nice little picture of a British soldier standing at attention. They were known for their standing at attention. Straight and hard. So whenever we have a piece of wood that's straight and hard, and we're going to use it as a mold support, that's called a soldier. Okay. Now looking at that, I should have said while we were looking at the mold. Now that's a cross section of a mold, just in case there's any question in your mind. So it's like somebody took a saw and cut that mold in half, and we're seeing a cross section of the mold. Those lines that I drew on those molds, okay. Now what we usually wound up doing is we usually wound up getting something like a piece of 1x1 from the carpenter shop, and while we were up there, we would take their disc sander and just sand some jagged lines, some almost like V-shaped depressions in the wood, so that when you rammed the sand around those soldiers, that the sand would have a way of gripping the soldiers to add even more strength to the soldiers acting as the mold support. Okay, so the sand wouldn't just slip off of the smooth wood, in other words. Okay, and we would wind up just going up there and getting some prepared wood, or maybe even just some scrap, like what you're looking at now. You got a pile of standard pieces of wood, like they would have it up there in the carpenter shop. They would have a pile of scrap wood. We wouldn't use their good stuff because, all we're doing is just, it might even be only a one-time affair. This might be a one-time, a once-in-a-lifetime mold that we got to make for the ship. And we would use their scrap, or maybe have a few small pieces cut for us, and then we would use them. Now, you being a backyard molder, you might not even have any of that. You might be, let's say you might have some woods by trees and stuff right by your land. You could go out and find some small, finger thick limbs that had fallen off the tree, and pick those up and use those. I mean, as long as they're not rotten, because what good are they going to be if they're rotten, and you try and pick up a mold and the weight pulls on that rotten wood and it just falls. Wouldn't do any good at all. But the good thing about using little branches and stuff like that is that they're not all going to be uniform. You're going to have knobs, you're going to have depressions in this odd curvatures in the wood that the sand will ram around, and it'll add more gripping force. Okay, so but the bad news is on that though. With lumber, when you use lumber, that stuff has been dried. Okay, and it's likely to have been in a place where it's not got much water in it at all. The stuff you find out in nature, that's going to be kind of wet. So if you have any chance whatsoever, try to dry those out as best you can. If you have them in a mold cavity, too near the mold cavity, you might generate steam, and it might be an expansion scab or something show up in your casting. So try and make, if you're going to get any of that nature provided wood, try to make it as dry as possible. You know, if you don't have to make your mold right away, you don't have to make the casting right away, put it in an oven and dry it out. You know, don't start a fire for crying out loud, but you know, dry it out. Okay, now, and those are mold supports that are called soldiers. Okay, now we've got gaggers, Gaggers, gaggers. Now a gagger is normally a piece of metal, like a rod. Okay, it can be a rod, it could be a round rod, it could be a square rod, it could be any shape that you want it to be. Okay, the gaggers are used to give support to hanging masses of sand, which would break under their own weight unless they're supported. Now, this information I'm getting directly out of the Foundry Manual, I'm giving you the actual definition of what a gagger is. Okay, gaggers should be cleaned and are coated with clay before use to provide a better bond with the sand. Care must be taken in the placing of the gaggers in the mold so that they are not too close to a mold surface where they would cause a chilling of the metal where it is not wanted. Many times a casting defect can be traced to a gagger located too near a mold surface. Now, in the Navy, there were occasions where we used nails to support the surfaces. You know, if we found that there was someplace there was going to be a very bad erosion problem, and we didn't want anything, like for instance, let's take that example again. We go that part that's holding right there. Let's say that we got everything turned 180 degrees, and that piece of sand that's standing there like a giant hill is going to be hit by the molten metal, and if we don't do something, it's going to be lifted by the molten metal and shifted sideways and cause a thick wall section on one side and a very thin wall section on the other side and ruin the project. Okay, now there's a fella in England, name is John. He does like the majority of his work, he does he does a lot of the machinist repair, machinist work and such, but he also does casting. And he has a project that I've seen him do a couple of times where he makes something out of brass, or was it bronze? I think it was brass. And the things that he makes has to do with the steam. It works with steam. Now, One of the items, and he rams these up side by side. One of the items has a square of sand that provides a void in there, so that basically what you're making is a casting that's roughly, let's see, 2 inches tall, and the sides are what, 3 inches by 3 inches, and the wall thickness, I can imagine just looking at it, would be about a half an inch. Well, the void in the middle of that is what's forming that wall thickness. Now, apparently in the past, and I'm only guessing because he never told us any story about why he devised this. What he's been doing, as he's been not putting facing nails in that sand. Green sand core is really what it is. It's a green sand core. It's forming a void inside that casting. And what he's been doing, pardon me, what he's been doing is, instead of putting facing nails down there to prevent the sand from being shifted or otherwise pushed, he's been putting screws down there. They look like wood screws, can't say. Anyway, it really doesn't make that much difference, because basically you're putting a piece of metal so long, I think they were maybe a couple, 3 inches long, down and acting as spikes in the sand to keep the sand in place. Okay, he never, the metal never touched them. They basically are just supporting the sand so that the sand doesn't get hit and get pushed around. Okay, well, the same thing is done by the Gaggers and all that. No, that's a lie. I was just telling you what John did, to tell you why you can use nails. Here's the thought I was trying to make, and I got lost. I saw a picture of an assembly of Gaggers in a mold, and they weren't simply being, used to support a hanging mass of sand. Okay, they had them laying sideways and horizontally and vertically and all through the mass. And they said that they were using it to just support the sand. I would love to see their logic behind that. I didn't see any reason, according to the drawing, I didn't see any reason why they needed those in there. But then, I don't think of any molder would ever go through the extra work of having to put Gaggers in a thing unless they found that they absolutely needed it. So it's just my ignorance that's not telling me why it's happening. A Gagger. Gaggers can be an L-shaped piece of metal, a rod that's been bent to have an L shape at the bottom, or a 90-degree, angle at the bottom. It can be in the shape of a Z. Okay, you can have it in the shape of a C, like this picture right here. This essentially is how we in the Navy used to use the Gaggers the most. Okay, we would have an area that would be hanging like that. And the best example I have is when we made ship's bells. Okay, we would wind up having the part that forms the inside of the bell would be hanging, and sometimes the strength of the Petrobond sand wasn't up to it. Okay, the weight of that green sand core being formed by the sand was such that whenever we would pick up the mold to remove the pattern, or after we finished getting the coat done and we were ready to put the coat back on the drag, as soon as we did this all nice and slow, nice and easy, no jerking about. We turn it over nice and easy, and suddenly, boom, we look down on the ground, and there's the gosh darn green sand core laying on the deck. Okay, prime example, and that was the one we used the most. So what we wound up doing is when we pardon me, when we started ramming up the internal portion of that bell again, we would either put soldiers in there that connected that hanging mass with the sand in the rest of the cope, or if we wanted to make certain we didn't have to mess with that again, we would make a couple of gaggers, ram those up inside the green sand core, and then, just like in this picture that I'm showing you, we would have the top portion of the gagger being supported by a cross beam, like another piece of metal or another piece of wood, that and that cross beam being supported by the sides of the flask. Okay, this allowed us to work with that the cope, and we knew that the gaggers were strong enough that the mass wouldn't fall unless we were stupid enough to jerk around with it. And there has been a couple of times where we would pick it up nice and easy. It would be thoroughly secured, okay, with that gaggers, a couple of 3 gaggers in there, and we would pick it up and we would turn it over, and we would look at it closely, and the base of that green sand core, the part that forms the inside of that bell, that the part where it came in contact with the rest of the cope, there was a crack all the way around. Okay, we would seat that back in, against the rest of the cope, and then we knew that the mold support was doing its job, and we knew that it was going to hold it when we were waiting to pour it. Okay, so you've got your gaggers that are L-shaped. You've got your gaggers that can be in the shape of a C. They also have gaggers out there that are in the shape of an S. Okay, those can be rammed up directly in the copes, and the S shape, or the round, almost I that you're forming with that top half of the S, those will be surrounded by sand and will provide a good support also. Just not as good as a C-shaped gagger that is being kept from moving with a cross beam on in the cope. That's a little bit more security. Okay, here's an old picture of a mold that shows gaggers in the cope. Okay, you can see how they would have that given good support throughout the cope. And here's another picture. It's got, it gives you labels on almost all the stuff that's in there, and it shows a couple of gaggers that the molders put in there. Apparently that they wanted to make absolutely certain that those pieces didn't fall, and we're going to be maintained in place until that got poured. Incidentally, if you start to look up the word gagger, okay, now in all innocence, the only thing that came to my mind as a molder, 20 years in the Navy, I knew what a gagger was. It's a piece of metal that you ram up in the cope. It's in an L shape, or it's in a C shape, or whatever. I knew exactly what a gagger was. Okay, my mind had that only in it. I started to look it up. I wanted to get some pictures of gaggers like the ones I just showed you. The very first time, all I did is write in the name Gagger. Okay, and boy was I surprised at what came up then. I'm not going to mention anything what I saw. You go ahead and just type in Gagger in your whatever you use to look stuff up. Look stuff up. If you're very, very sensitive about some of the less savory parts of life, don't do it. I had to look over my shoulder and make sure my wife wasn't there watching me work, because I didn't expect that to come up. All right, so got off of that website real quick, and then wrote in metal Gagger, and then I looked up foundry Gagger, and I put all the stuff that had to do with the foundry and molds and sand supports and all that stuff added to the word Gagger, so that I never saw that stuff came at me again. That was kind of, I mean, I'm no prude or nothing, but gee manetti. Wow, that was rough. Anyway, so be careful when you look stuff up, because stuff, I mean, if you're not of a certain culture that uses that word Gagger all the time, cool. You might be surprised at what you look up. So, Gaggers. Oh, and here's another, this next picture right here, this is another way of that we used to, support hanging masses of sand, okay? Basically, you just get a piece of metal, like a big washer, or you can make your own, get a piece of sheet metal that's not all real thin, something that's, not an eighth of an inch, but something that's thick enough to where it's not going to automatically bend if any pressure is put on it. It's got to be somewhat thick enough to be stiff. Drill a hole in it. Have a bolt or a piece of rod, threaded rod, long enough that you can, that you can get it above the, surface of the cope that after you strike it off, and then you can either, usually it's best if you put a piece of wood across from side to side, from one side of the flask to the other side of the flask, so that you know that the sand isn't going to give way when you try and work with that cope. Okay, you just basically you ram that up, and then when you put your wooden support from side to side, after you drill a hole and it goes over that threaded rod, let's say it is, put the before you try and take the mold apart, you put the washer and nut on there, and give it a little bit, like finger tight, just enough. You don't want to pull it through the sand and make the sand buckle on the inside of the mold, but you want it to where it's not going to suddenly drop. Even a little bit, not even 1/8 of an inch, 1/16 of an inch. You don't want it to drop at all, because if it drops and it has a crack at the base of that hanging sand, that molten metal is going to flow into there, and you're going to have that much more of a mess to clean up when you pull your casting out. Okay, all right. Now that subject is Gaggers. Okay, now we're going to talk about supports for your cores. Normally, your cores will have supports, core supports on the end of the pattern's core prints. Okay, where if it's a cylinder shape, you'll have a core print on both sides where the cylinder exit the mold cavity, and that'll be held in place. Okay, if it's sufficiently stiff, sufficiently thick, and you've put supports inside the body of the core so that the core doesn't move at all when the metal flows around it, that'll be fine. But there'll be occasions when, let's say, you have a longer than average cylindrical core that has to be supported, because even with the rods rammed up inside the core, there's still a little bit of a droop in the middle of that core. If it does droop, okay, that means that there's on one half of the core, it's going to be crushed. That would be the top half of the sand is going to be crushed, and then the bottom half of the sand on the same plane is going to be pulled apart, like split. Okay, your metal is going to go in that split, and that crushed sand that's sitting on top there is going to flow with the molten metal. Okay, so it's going to be included. It's going to be a sand inclusion, in other words, and it's going to be casting defect. So if when you find that you're putting that casting, or rather that core, inside that mold cavity, and that it's even the tiniest bit is drooping and making the center of that core start to break up, then you have to put what's called a chaplet inside that mold cavity to support both on the underside and on the top of that core, so that when it's waiting to be poured, the weight of the core doesn't ruin the core and is supported on the underside. But you have to have something on top also, because don't forget, you're going to have a certain amount of flexibility because of its size, because of its length in that core. And once that metal fills up the bottom half of that core, mold cavity, don't forget, the sand is displacing that metal, just like a piece of wood displaces water when you hold it underwater. Okay, there's going to be a certain amount of buoyancy being exerted. The force is buoyancy being exerted against that core, and so if you don't have something to keep the center of that flexible core from being picked up, from being pushed up, okay, you're going to have a crack again in the bottom, or rather this time the crack is going to be on top, and there's going to be a crushing effect in the bottom. Okay, it's going to happen. It's going to be a defect, whichever way you look at it. You have to support your cores, no matter which way you look at it. Okay, so in the case of a long cylindrical core, even a long square core, maybe you've got a core that's fairly long and weighty, that's in the shape of a square. Okay, it's possible, not likely, but it's possible. You're still going to have that problem with it sagging or lifting, and you have to support that core too. Now, all right, now we're gonna use an example. There was one time where we needed to make a base for what's called a divot crane, or it's otherwise also known as a jib crane. Okay, now a divot crane, I think those are terms. A jib crane might be more maritime terminology, and a divot crane might be more Navy. I'm not certain, but I'm pretty sure that they're basically the same device. Okay, the ships I was on, they had divot cranes or jib cranes. Oh, okay, I'll leave it one name. We'll call it a jib crane. Okay. Now on the ships I was on, and all I was on tenders, the only time you had to use any jib cranes was when you were taking the motor whaleboat off of the boat deck, swinging it out over the ocean and lowering it down into the ocean, so that, let's say you had somebody fall overboard. It was the motor whaleboat that you could get into the water and save the person that would be put out there in the water fastest. Okay, here's a picture of the USS Yosemite. Okay, we had So a couple of really big cranes on the boat deck area that, we would pick up supplies, put it on the boat deck. The supplies would be taken down by whomever, ordered it, or the supply department. We would use the big cranes to pick up the 40 footers or the 50 footer utility boats that you probably see up there on the boat deck. And then just on the forward portion of the boat deck, and I put an arrow there with a little red arrow, that curved piece of steel that you see there, it's like it's like an L-shaped piece of steel, but instead of having a sharp edge, they put a curvature on there so that it would survive longer. It'd be stronger, flex better. All right, let's go back to this. Somebody tried to call, and I didn't even think about it. I'm normally I just ignore, unless it's the wife on there. I ignore the calls, and so my mind didn't automatically say, "Hey, turn off the recording," until that noise went away. Now, back to the ship. Those little curved stanchions, you might call them, like they were big pieces of pipe, like 6-inch, I think I'm pretty sure they was like 6 inches in diameter. They have on the end of them, on the one end they're in a base that supports them. On the other end of that curvature there's block and tackles, okay? And then how they were used is that they would, the bosun mates or whoever was going to be launching the motor whaleboats would lift the motor whaleboats out of their cradles, turn those divot cranes or the jib cranes, the ends of them towards each other, and then continue outwardly towards the edge of the skin of the ship, and where the motor whaleboats would be hanging by ropes or cables, depending on what they had. They had them on. I think they were roped, and they would lower them down into the water, and then disconnect them from the pelican hooks, and then they would zoom off to whatever they had to do, like pick somebody up who fell over the side or whatever. Now, the base of those jib cranes had to have the ability to, that the base was attached to the deck, okay, so they wouldn't move. Now, these were made out of steel. We made them out of steel to replace the ones, I guess they got all rotted up, and those style bases were no longer, they weren't able to make them anymore. I mean, rather, they weren't able to buy them anymore, okay? So they brought the job down to the pattern shop. Pattern shop made the patterns for the bases and the core boxes, and then they brought that all down to the foundry, and we made a couple of them, and they came out good. But the deal is that it had to be, let me see, I don't want to get too far ahead of myself. The base that you see in the yellow jib crane, okay, now that one is assembled by somebody who cut plate and welded that all together. Ours was going to be stronger because it was going to be a single piece of metal, single piece of cast metal, okay? It was taken to the machine shop. It was heat treated and normalized, and all the stresses that came from casting. The casting process were neutralized, and then they machined out the center so that the 6-inch stanchions could fit inside it. And I think that was basically all that was in there. I don't think they had any bearings. I can't remember though. And you know, they went up there and they bolted and welded that to the deck. Okay, so but we had to cast it in such a way as that we had to support the core that we had to make. Now here, I'm going to show you. I showed you the yellow jib crane. Now that kind of jib crane was not only, you know, that we didn't have that exact type on the ships. Okay, the fact that, you know, you have a portion of it that goes up, and you have a portion of it that goes at a 90-degree angle to the portion that going vertically. That's the same as on the ship, but it was just a piece of bent stanchion. That's what we had. This kind right here, the yellow one, that is the kind that we had over that was attached to the pier. Okay, and it basically did the same thing. Any small boats that needed to be put up on the pier, it would grab them, and or anything that was in the small boats, like let's say somebody came in, the Coast Guard came in one time and had to offload some of the dope that they seized, and they used the jib crane to pick it up and put it on pallets, and the pallets were put into the back of a security vessel, not vessel, but a security vehicle, and it was taken to the Treasury Department. I don't know, can't remember who it was, but it was taken away. But they used the jib crane to take it out of the boats. The same kind of base is you'll see in this picture is used on, you know, little movable cranes that you have in the shop. If you have the type of crane that has to, you know, pivot a certain amount, you know, I mean, to rotate, I mean, a little bit, a certain amount. Okay. Of course, you're not going to be picking up heavy stuff, because as soon as you take it out of its comfort zone, the whole thing would start falling over. But you know, it's that you see right there that it's got that same kind of base as the yellow one did, and it's the same kind of base that we had on the Yosemite for the divot cranes or the jib cranes. Okay, and this is a picture, essentially what the mold looked like. Okay, we would have, essentially, that's basically what it looked like. Okay, we made it out of steel, mild steel, and we did use Petrobond powder, or rather sand. Now, Petrobond sand, actually any kind of sand, even if it's water-based sand, there's a certain amount of burn-in that you'll have. Petrobond was kind of a little bit worse, because you burned up the oil that was being used and the P1 catalyst that was being used, and a certain amount of the what's in the Petrobond powder, the clay in the Petrobond powder. Okay, so you wound up, you know, whenever you poured any steel, when we poured any steel, we wound up having, let's say, a 1/4 inch to a 1/2 inch burn-in, where we would just use our trowels and pick that out of the sand and throw that away, because it was basically ruined sand. Now, once in a while we'd make something small out of steel, and it would only be about 1/8 of an inch burn-in, and we would just put that in the molar and distribute that ruined sand throughout the good sand, and it would still work for, you know, forever. Okay, but you couldn't add a lot of that to the rest of the sand and expect it to you know, make a good plaque or make a good watertight door dog or any of that. So we would, for stuff that really got burned in bad, like this mold, we would, you know, pick that out of the good sand and just toss it. Okay, now what I was going to do, you know, well, I'll show you before I go any further. Those bases came out good. Oh, Pardon me, got to stop again. Talk about a pain. Anyways, so, you know, as you can see in that mold, we had to have something to support that core, to keep it from being sheared off where the core print was at the edge of the mold cavity. Okay, and we use chaplets. Now, when you use a chaplet, the chaplet's got to be the same thing that you're pouring. Otherwise, you're going to be doing a whole lot of extra work trying to drill out the chaplet, removing the chaplet, and trying to fill in what you know where the chaplet was with the material that you're casting. Okay, we had. I'm going to show you some chaplets. Now, in that portion of the mold, that was a round surface in there. Okay, this group of chaplets, as you can see, are curved. All right, the chaplets that we formed ourselves. Basically, it was almost like the one all the way to the right. It had the curvature that fit both the core on the top side and a curvature that fit the mold cavity on the bottom side. Now, don't get yourself a huge piece of steel or a huge piece of metal and put it through a roller and use it like a big thick thing. It's got to be thick enough to support the core that you're trying to keep from moving, but thin enough that the molten metal, once it flows around it, will either totally bond with the chaplet or destroy the chaplet after the chaplet's been replaced by the molten metal. Okay, don't forget the molten metal will be lifting the core with a certain amount of buoyant force. So once the core is lifted by the buoyant force of the molten metal flowing and the chaplet gets destroyed, you don't have the chaplet, you have to worry about the core falling because the chaplet's gone. You just have to worry about the core lifting and, but the other chaplet was there. All right. So you've got that group of chaplets that are preformed. You form your own, or you got this group of chaplets that can be used. Basically you've got a flat bit, and you got another flat bit that is on something that's like a screw. Okay, you got the two platforms, and they're adjustable. You there's a certain amount that you can't move past a certain amount, so you buy the ones that's going to be right for your special project. Like in this picture, okay, you have a long core. Now this is just like a long piece of mold, a long mold cavity that they've taken cuts on, so you're not going to see the ends. But here, let's say that's pretending that that's the center of that void. Okay, you put a couple of those adjustable chaplets in there, and in their case, they went and put a couple of flats on the core. Apparently, when it comes to that, as soon as those chaplets are absorbed by the molten metal, and those impressions are filled in with the molten metal, they'd have to take that to the machine shop and machine out whatever it is they had left over. Anyway, so these are, there's dozens of types of mold cavities, mold supports that you can buy out there. These were the ones that we mainly relied upon in the Navy. Okay, they're very basic. They do the job. You don't have to spend ungodly amounts of money on it. If you're the least bit handy with a drill, and a hammer, you can make your own supports. Okay, and this is the reason why I even mentioned these, because these are the kind of things that you can make yourself at your own home in your backyard and not have to go into debt for. All right, these things we have easily in Home Depot or Lowe's or any of the other places that's got hardware. You can make these things so that you can have the support you need. Now, I'm going to show you the Yosemite again, okay? And this is the very end of this talk, but I wanted to point out something. Remember the old saying, "What's old is new again"? Now, if you've been paying the least bit of attention to the newest destroyer, the USS Zumwalt, you'll notice that they've made a little bit of a change on the bow. The pointy end of the ship, the part that cuts through the water first, they've made a bit of a change. Okay? Look at the Yosemite. Now the Yosemite has basically a straight up and down bow. Okay? There's a reason for that. Number one, we've got a lot of mass being pushed through the water, and so we're not going to go fast like a destroyer. We're not going to go fast like a cruiser. So all we have to have is just a straight up and down pointy end of the ship. Okay, the front of the ship. Most of the warships that I've seen, you can see it in this picture, had a bow that, the front end of the ship was farther out. The angle went to where it cut through the water, but it wasn't straight up and down, and the bottom portion of the ship wasn't ahead of the rest of the ship. The very top on the main deck portion of the ship was pointed out, was hanging out farther ahead. Now that was supposed to be a good design, so that the ships, when they started really going, they could just cut through the waves easy, and and then I guess it worked pretty good. Somebody, however, decided that they would want to go to a difference in the newest destroyer. Problem is, it's not new. Now this picture you're seeing right here is the battleship Kearsarge. Kearsarge? I think it's Kearsarge. This is around the year 1900. Okay? Take a peek at that bow. Alright? See how it's formed? And you also, before I change to the newest destroyer, you can see all kinds of divot and cranes on board ship, forward and aft. You see all kinds of little cranes. None of the big cranes, just all kinds of little cranes that they use to pick up ammo, and they pick up their ships, their small boats, and all that. Okay, now that's the year 1900, circa 1900. That's the bow that they had on the ships back then. Here is the year 2016. The USS Zumwalt, the destroyer DD-1000, and see, they've gone back to that style bow. I don't know if they forgot that we used to have that bow before, and that there was a reason why we changed from that bow to the bow we used to have when I was in the Navy in the 70s and 80s and 90s. I think I don't know. I guess in the 40s maybe they changed. Can't tell. I never looked it up, so I don't know. But the old saying, "What is new, what is old is new again," has been proven once again to be accurate. Okay? So I hope you've gotten something out of this video. I know that you're not always going to be just making things that are going to be flat. So you're going to need the information for mold or core supports. So try to pay attention to this video, and I hope you have the best of luck in whatever you're making. And for those of you who knows what this means, Liberty Call. Oh, by the way, Randy, you go ahead and get the trash out today, and Bill will get the trash out tomorrow, okay? All right. Liberty Call.